Welcome to Forging the Future, Decarbonizing the Steel Industry, a Hatch podcast series. I'm your host, Takashi Sachdeva, and invite you to join us on a journey through the challenges and innovations in iron and steel production. Discover how Hatch's century of expertise is shaping a sustainable future for the steel industry. Stay tuned as experts from Hatch share their insights on technology, market dynamics, and the path to decarbonization. Welcome to episode 9 of Forging the Future, Decarbonizing the Steel Industry. Today, I am pleased to introduce our guest speaker, Ron Ashburn, Executive Director of AIST, Association of Iron and Steel Technology. Joining Ron, we have Hatch's Global Director, Iron and Steel, Paul Towsey. Welcome to the show, Paul and Ron.
Thank you.
Thanks, Takashi, and thanks, Ron, for joining us. Our first guest on our podcast series. So honored to have you with us today.
Well, happy to be here, Paul. Thank you, too.
Awesome. Firstly, I'd like to congratulate you, Ron, and all of AIST for developing and publishing your recent report, Roadmap for Iron and Steel Manufacturing. I've personally given it a read, and it's commendable how much good knowledge and information is compacted in that one report. Discussing and focusing on different themes that the steel industry is going through and the transition and the challenges. Before we dive into some specific topics, are there any key themes you'd like to share with our listeners from the report?
Sure. Well, maybe just the genesis of the whole report. It was early 2022 when the NIST group, that's the National Institute for Standards and Technologies, and they're housed within the United States Department of Commerce, approached us with a grant to develop a roadmap to enhance the competitiveness for the U.S. steel industry. And how were we going to look at the industry over the next generation or two to make it more efficient, ultimately more green, so decarbonizing it, and to look at a variety of technologies, the infrastructure to support the supply chain of our industry, and the workforce developments that were needed there. We published the formal version of the roadmap in May of 2025, and the perspectives are now in time. They will change, I'm sure, but we have a solid record of the information that's needed to get us to an efficient, competitive industry. I would say that the takeaway from the roadmap is the necessity for the world's industry to decarbonize. So it's not just an advantage for the U.S. industry, but it's really a global one that I see recognized. What is different, what's unique, is the timeline to decarbonize to what I would suggest would be a net zero steel industry. That's what's different. There's disparate technologies and certainly transition times to bring us to net zero, but there's a lot of good that can happen from that. There's no silver bullet, though. There's no one pathway to decarbonize. There's many technologies and many timelines that will get us to decarbonize. That all said, I would say, though, metaphorically, the genie is out of the bottle, the genie being green steel. We will never go back to producing unsustainable steel. So that's sort of my summary, I would say, for where the roadmap is today.
Thank you for sharing that. I like that. As part of Hatch's Forging the Future campaign, we've been hosting some surveys on social media platforms such as LinkedIn to gauge what the public's thinking. I'd like to share some of the questions and get both the viewers' insights on them today. Starting off with our first question, which emerging technology will have the biggest impact on sustainable steel production by 2030? There's 4 options: green hydrogen for reduction, carbon capture and storage, AI-driven process optimization, or blast furnace electrification.
Well, I see from the data that they're all fairly evenly weighted from your respondents. And that underpins the notion that there is no silver bullet, right? There's many pathways to decarbonize our industry, and we need to pursue all of them, really, to be efficient. I think it comes down to raw materials, to energy, to policies in various regions. But the one response there talks about the AI impact. And I think AI will have an insatiable appetite for the various thinking processes around our industry. That's a given. Now, look, AI has been around steel for quite some time, actually, probably at least a decade, depending on how you want to define AI. And the steel industry has a way of humbling even the smartest of people. And I think it'll have a similar impact on the various bots and agents that AI will deploy on us. But over time, we'll get there. So the opposite of the AI question is the doing processes. So the thinking processes, AI's got a role. But on the doing side, we really need to focus on developing a workforce that can do these things. And that spans the spectrum from innovation all the way through maintenance and reliability. We need people with the skills to do things. And in that respect, the roadmap has guided us to where looking at trades, trade schools, tradespeople, and developing the education and the curriculum to get them the skills that our future industry workforce will need.
Mm-hmm. Paul?
So I think from our side, and we've had the opportunity over the years to study a lot of the upcoming new technologies, a lot of the new ways of making steel, of making irons. It's clear there is no silver bullet, as you called it, no one single pathway, and it's going to vary a lot depending on the region we're working in, the availability of natural resources, the availability of green power, and other matters such as that. One thing I think there is some common ground is around the raw material supply base. If we can improve the quality of the iron ore that we put into the process, we can use less coal, less carbon, less fossil fuels. Furthermore, if we can increase the quality of scrap, and then where we need metallics, if we can find a way of producing those in a cleaner way, such as using natural gas in a direct reduced iron process. It's already available today. It's already on the market. Many producers have installed them, and many more have announced that they're going to install natural gas-based DRI. DRI, especially when combined with carbon capture, can really offer a credible pathway to a net zero steel production future.
Mm-hmm.
I'm glad you touched upon some technologies and processes available today to implement this change, which brings me to my next question. What, in your opinion, is the low-hanging fruit that the steel companies can implement to both reduce costs and emissions?
Mm-hmm. Well, I'd like to summarize where the roadmap guided us, which was the various pathways of technology development. And we've brought a slide that would like to kind of review to help bring some structure to this conversation. And within the roadmap, we've created 4 pathways or categories of technologies. The first would be energy and material optimization. So a lot of technologies can fit into that category. The second was the electrification of combustion processes that are typical today. The third would be the use of low and no carbon fuels. So think hydrogen, natural gas, etc. And then the fourth was carbon capture, storage, use and storage. And those 4 categories span the spectrum from mitigating carbon that's emitted all the way through direct carbon avoidance. So again, underpinning the concept that there are many ways to get to the promised land of sustainable steel production. Now, within those 4 categories are some cross-cutting themes. I would say digitalization AI. This is an important concept that cuts across all categories. The infrastructure for the supply chain to bring the essential needs of the industry, and then the development of the workforce. All 3 of those cross-cutting themes migrate through the 4 categories. Now, the second slide that I would like to talk about is also within the roadmap, and it summarizes over 30 major technologies. And if you looking at this slide, along the x-axis is a timeline. It starts at 2030 and it runs up to 2043. So about roughly a 15-year window outlook. Now on the y-axis is the impact on carbon emissions reduction. So how big of an impact can we make with a certain technology? And that's expressed in terms of kilograms of CO2 emitted per ton of steel produced. So when you look at the various spheres, we call them bubbles on the chart, you can move around and to see what the impact is. Now, higher up on the chart, the bigger the impact. Further left on the chart is the closer timeline to commercialization. So if we look at some of those, and we've highlighted a few on the image, scrap optimization comes to mind as a low-hanging fruit. We need to do more of what we're already good at, which is utilizing metallic scrap through an electric arc furnace. Now, AI, I think, is going to have a big role there as well to optimize scrap to help us sort it better. And that will, I think, bring more emphasis on greening of the grid, the electrical grid, because the best way to decarbonize is to recycle scrap. And in order to melt that electrically, we need to then think about greening the grid. So we need to talk about our utility providers and bring them into the discussion to really take full advantage of decarbonization through the EAF process. Now, there are certainly other technologies that we feel are important for the future. The electric smelting furnace is one that we have our eye on that we think has the potential to replace the blast furnace. And then, of course, the applications of hydrogen for both reduction and heating or energy provisions. So that's what we're looking at. And you can move around that slide and see a variety of different topics that are all highlighted within the roadmap.
Go back to what you said about electrification. I do see that as one of the really quick wins, where things that today are heated with fossil fuels, burners, anything like that, that can be replaced with electric heaters. That's an immediate switch out that has an immediate impact on carbon emissions and fossil fuel consumption. You mentioned the ESF there in your review. At Hatch, we're particularly excited about the ESF, the electric smelting furnace, or at Hatch we call it CRISP, continuous reduced iron and steel production. It's something Hatch has worked on with many years, and when coupled with DRI, can have a significant impact on carbon reduction, effectively replacing the blast furnace through a combination of reduction in DRI and smelting in an electric furnace, which also does the gangue rejection. And it also allows us to use lower grade raw materials. Also want to circle back to what you said about AI, and my personal opinion on that. From what I've seen today, a lot of it seems to be more focused on advanced automation, not necessarily what I would say is true AI. There's definitely some decision-making tools out there. They've been around for many years. The problem that I've seen is a lot of the time they're at the back of the control room and not really utilized the way they should have been used. As we move forward and trust develops between the producer to trust in the decisions made by AI, I really think we could see meaningful change. And AI can really impact the way steel plants operate, which means operating more efficiently, which means overall a more efficient and less carbon intensive process.
So you've both touched upon what are the different options. I'd like to have your perspective on how do we get there? What actions does the industry need to adopt to achieve technological, economic, and environmental sustainability?
Well, it's going to take a lot of collaboration, I would say. We need to broaden the coming together of the academic community, certainly the utility providers, because energy is such an important part in the decarbonization process. And I would add to that group public policy, right? Steel is a very capital intensive business. And when we talk about decarbonizing steel, it takes the business case for making steel a whole order of magnitude higher. So there's a lot of risk there, a lot of uncertainty that can develop from those discussions. The academic community can help us to de-risk advanced technological developments. I would say that the public, or I would say the utility providers, the energy providers can be hyper-focused on green energy provisions. That's what we really need to get to a net zero industry. And then, of course, we need the public policy framework to de-obstruct that process. We can't be constantly running into impediments on permitting restrictions. We need an environment that is conducive to a successful outcome to get to net zero. It's fraught with challenges for sure.
So universities, utility companies, policymakers all have an important role to play, as you mentioned. I also think technology suppliers and engineering companies such as Hatch also have a huge role in bridging the gap, or bringing all of those collaborators together into one place. At Hatch, for example, we cover the infrastructure side, we cover the energy side, as well as the metals production side of things. And bringing all of that together as one cohesive solution, I think, is really an important step in bringing all of this together.
Yeah, I don't think you can overemphasize that point. And it's great to see companies like Hatch really engage in that collaborative effort. It's an imperative.
Now, this brings me to my next survey question that we post on what is holding back the steel industry transition. Despite growing demand, what's holding back large-scale investment in green steel? We had 4 different options here again: high upfront capital costs, uncertain ROI and market demand, lack of infrastructure, or regulatory uncertainty.
Yeah. CapEx uncertainty, it's a reoccurring theme that we do see. Steel making is a very capital intensive business. We know that. It's also a process know-how intensive business. There's a lot of knowledge that is required to be a successful steel producer. And yet over 100 countries make steel around the world, which is always amazing to me that they've overcome those barriers to entry. And yet they know it's worth the effort, because steel manufacturing is a significant driver of economic GDP, which every country wants to have. It is the very foundation of a manufacturing economy. Now, uncertainty, right? It's interesting because we track what's called the uncertainty index, which is a metric that tracks the number of terms the word uncertainty, or its variant, appears in the quarterly reports of the EIU, which is the Economist Intelligence Unit. So they report quarterly on a variety of economies around the world. That uncertainty index today is at an all-time high, far surpassing the previous all-time high, which was concurrent with the pandemic, which seems to make sense. But the world is a unique place today. Uncertainty is rampant. Uncertainty is not a good thing. That can delay decisioning. We call it decision atrophy. And that makes it challenging for long-term strategic planning for anybody, let alone the steel industry. We need to work our way through it. Decarbonization in itself is inherently uncertain because of the many pathways to it. And I believe we have to be realistic about the transition era to get there. This won't happen overnight. It's not going to get there by 2030. We need to think realistically about a 15 to 25 year transition era, and we need to get through that as safely as we can.
Yeah, I think the uncertainty, one area or one location where we're really seeing that is in Europe. A lot of steel companies in Europe had big plans supported by local and regional governments to help them with grants, subsidies, loans to implement green steel technologies. In many cases, those projects have been delayed, as you said, due to uncertainty for various reasons, due to policy uncertainty. And one of the big things you mentioned, CapEx, this stuff's expensive, but also in a lot of places, such as Europe, it also impacts OpEx. Switching from coal, which is relatively cheap, to processes that need green power, natural gas, where they aren't naturally available at low cost, really impacts OpEx. So that increases their cost base. And to remain competitive, they need policy to help them there. And that's where there's some uncertainty and what appears to be lack of confidence in the policy being sufficient to protect them and allow them to push forward with those large investments. However, there is an area of optimism around some projects in Europe that are really being pushed forward by new companies to the market, startups that didn't make steel before ever. There's probably 4 different initiatives happening in Europe right now. And they're really the companies that are going to push the boundary. And then once proven successful, I think we're going to see a lot of the other companies following.
Thanks to the both of you. Such transformational technology development is often beyond the capability of just one steel company. We need companies to come together. And you touched upon this earlier, that collaboration is absolutely needed to accelerate change. How can we perhaps encourage this in today's competitive business climate?
Yeah. Well, it has to happen. We need that collaborative consortia-based R&D to happen to de-risk that. We need the technology suppliers to be involved in that, certainly that the steel producers, the academic community. In the United States and throughout Canada, we have steel centers. These are usually hubbed at a university that involve steel producers and technology suppliers. They maybe need to have more policymakers involved in them, but they de-risk through risk sharing. Test beds are called out in the roadmap as an important aspect to de-risk significant innovation technology that we can test at scale and share the risk in the event of failure. There are successes, but there's also failures and setbacks. And mitigating that risk is very important to sustaining the business case because companies still need to remain profitable through the transition era. Any company that goes out of business to make green steel is a significant loss for this industry. We can't let that happen because that will only enable the unsustainable steel producers, I say non-green steel producers, to continue operating. So these risk sharing, very important. The steel centers, and they exist around the world. It's not unique to just North America. I think the EU has them, Japan has them. The STEP comes to mind in Europe, CRC in Australia, the Greens program in Japan. These are all proven methods for collaboration to de-risk. And we need to nurture that. It's very important.
Very well said.
So completely agree, Ron, and a shout out to AIST with the forums you're putting on a regional basis to really bring regional players together. Obviously, things are very different by region, as we already talked about. In Europe, things are different. The Middle East is different again, and the North American steel industry, as you already said, highly focused on electric arc steel making. I think one area of collaboration that's really important is the whole value chain from the iron ore producers, the scrap collection companies, integrating them with the steel company, and then the end consumer, whether it's the automotive industry or the construction industry, bringing all of those people together. The end users have made commitments to be more sustainable. The miners and the scrap companies have made commitments to be more sustainable. It can't all be on the steel producer in the middle to take the responsibility to make that happen. It takes everyone to get together and work on a solution together. And so that's where I think collaboration is hugely important. And events that are put on by AIST, by World Steel, for example, are really important to force that collaboration.
Mm-hmm.
Agreed.
We touched briefly on scrap-based steelmaking earlier. I want to know, can a more sustainable steel production model be based on scrap-based steelmaking? Will we have enough scrap globally by 2050?
Well, the short answer is absolutely yes, right? EAF steelmaking via metallic scrap is a very proven process, certainly within the United States. The U.S. steel industry has shown that you can transition from a blast furnace BOF model to a scrap-fed EAF process model and be successful at it. The U.S. has been perfecting EAF technology for over half a century, so we're very, very good at it. Again, I'll mention that process-intensive know-how is critically important, just as important as capital intensity for our steel industry. Yeah. The EAF solution has some prerequisites, though, right? You need to have a strong electrical grid. You've got to have the power. And you need to have a scrap infrastructure to be able to reclaim the scrap, to process the scrap, to optimize the scrap, and to deliver the scrap. So in the absence of those elements, an EAF model fed from scrap can be challenging. And I think for that reason alone, we just can't look at the EAF model fed from scrap as the silver bullet. It's not. There's many parts of the world where that infrastructure doesn't exist. So we've got to develop other technologies, some electric-based like the ESF, and others that maybe we can chat about later.
Will we have enough scrap globally by 2050?
Well, to look at that question, you have to look at steel production today, right? If we go back to, say, 2004, that's the year the world first made 1 billion tons of steel in a year. And let's just jump ahead one generation to, say, 2024, when the world nearly made 2 billion tons of steel in that year. There is a dramatic ramp up of steel production globally. All of that will come back to the scrap stream eventually. So end of life for most steel products is somewhere between 25 and 40 years on average. So the steel produced 25 to 40 years ago will come back as scrap. And if you look out that timeline, we're probably in that range of 2030 to 2050, when significant steel production will revert to what we would call obsolete scrap, end-of-life scrap. So the answer, in my opinion, is yes, there will be enough scrap. However, that's going to depend on steel demand. And if steel demand continues to grow, if EAF production routes continue to grow, that would put some pressure on the scrap industry itself. I think the biggest risk is not the technology of scrap. We're going to get better at optimizing and sorting scrap and even utilizing lesser qualities of scrap. That's going to happen. The real risk is a political risk where trade flow is restricted for scrap around the world. We're going to start to limit the movement of scrap. We already see that today in certain Asian countries. The bottom line here is scrap will be available, but it might not be available in the regions we need it.
Mm-hmm. On that note, what about DRI and pig iron, both in US and elsewhere?
Yeah, well, certainly for decarbonization, DRI and pig iron are essential for several reasons. One, they can dilute lesser qualities of scrap, and they're also a hedge against scrap scarcity, where scrap becomes prohibitively expensive. So DRI and green pig will be absolutely part of the decarbonization equation for sure. I'd say that if we can combine the electric smelting furnace, so DRI through an ESF, and be able to use a lesser quality of iron ore pellet, like a blast furnace grade pellet in that process, then we're really on to something. And this is when I would come back to say, within the roadmap, we see the ESF, electric smelting furnace, potentially replacing the blast furnace. And the world makes about 70% of its steel through the blast furnace. So this is a disruptive technology. This is a game changer. And I'm going to lean on Hatch here a little bit because ESF technology is a bit of an enigma for the industry in general. But Hatch has been involved in ESF technology for a long time, smelting different metals through the process route. So I want to put it over to you, Paul. Do you think the ESF technology can replace the blast furnace?
For sure we do. I just want to go back to what you said about scrap. I agree totally. The scrap pool is going to grow. It has to grow because we've made more steel. Therefore, we're going to recycle that steel as it comes back into the scrap market. However, I also think steel production will continue to grow, no different than it did from 2004 until now, as countries continue to develop, as the people within there consume more steel per capita. The requirement for steel is going to continue to grow. So we still see that 1 billion tons of iron ore needs to be converted into iron that needs to be converted into steel. Traditionally, that's been done in the blast furnace, as you said. And as we move forward, there's a good opportunity here to go through the DRI ESF route to replace the blast furnace, especially where blast furnaces are older, smaller, and reaching end of life. One of the things that's held it back up to now is scale. Scale's important, but we're already seeing DRI plants coming online at 2.5 million tons, even talk about bringing DRI plants on at 3 million tons. A plant of that size, combined with 2 of the largest electric smelting furnaces, can replace a whole blast furnace. The reduction's done in the DRI module. The smelting and gang reduction is done in the furnace. And it ties in really nicely because you're making the same hot metal. So the same hot metal that would have come from the blast furnace can now go directly to the steel shop. Why is that important? It's important because if you switch the whole steelmaking process, you have to get recertified for some applications, such as automotive. If you can supply hot metal directly to the steel plant, not touch anything downstream, there is no requirement for recertification. So it's a really elegant solution, and we see it as a really good opportunity. We've been talking with a lot of our customers about implementing the technology, and clearly I think most agree that it's an excellent alternative to the blast furnace. However, we're waiting for that first mover. I think a lot of the steel companies we've been working with are all looking to be first to be second, if you like. They don't want to be the first ones to do it at that scale to replace potentially up to half of their steel production with this new route when nobody currently is doing it at that scale. So one of the things that we see is really important is proving that technology with any grades of iron ore available on the market today. And that's why consortiums such as NeoSmelt in Australia, a combination of BlueScope, BHP, Rio Tinto, Mitsui, and Woodside Energy is really important. They're developing a pilot plant in Australia that's going to prove the technology at a reasonable scale that we hope will enable the steelmakers to have the confidence to move forward.
Mm-hmm. That's exciting to hear, actually. I think the ESF has great promise for our industry to decarbonize.
Mm-hmm. You've both highlighted on electrification and the importance of electrification in making this transition happen. How do you see this advancing, and what players need to be involved to accelerate change?
Yeah. Well, I feel that electrification is upon us, really. We need to involve, and if think about the EAF process route, fully electrified generally, ostensibly thinking. We just talked about the ESF. There's a variety of other reduction technologies, Voltron, Electra, other companies are out there that are utilizing electrons to replace carbon in the reduction process. Some are high temperature processes, some are lower temperature processes, but they continue to advance. I think what we really need to look at is the greening of the electricity that we're providing to the industry. We've got to get the utility providers in sync with our needs. and the public policy makers have to be in sync with that. And there's one real key interdependence here that should not go unsaid. If we're going to really electrify combustion processes, we need to understand the interdependence, that we will not build a green energy economy without a steel industry. And we can't build a green steel industry without a green energy industry. So green energy needs steel, steel needs green energy. That fundamental interdependence, which is inextricably linked, we need to do a better job educating our policymakers about that interdependence.
Electrification is good, but the electricity that supplies it, those electrons need to be green. If they're coming from coal-fired, it's better to use that coal to make steel than it is to make electricity. So the grid needs to be green, but two, the grid also needs to be reliable. Renewables have their challenges because they can't necessarily be 24/7. And so that's where we're somewhat excited to see the development of small modular reactors, or SMRs. They can provide a base load of electricity to the steel plant. They can be located close to the steel plant, and they're coming online by the end of this decade. So, what does that mean? It means lower permitting times for nuclear power, and it also means smaller exclusion zones. So those plants can be dedicated to the steel plant, supply reliable, clean power to the steel plant, and really help the transition move forward. But like we said before, it needs a lot of collaboration between the energy partner, the steel maker, to bring everything together.
Green electricity takes me to hydrogen. How do you see hydrogen playing a role in replacing fossil fuels in the future?
Well, I think it's fairly well known that hydrogen has a lot of potential, right? As a reducing agent to replace carbon, and as a fuel, as a reheating fuel to burn more cleanly with water as its byproduct. The process adaptation to use hydrogen is evolving. I'll take DRI as an example. Most DRI modules provided today are hydrogen ready. They're going to probably start generally with natural gas, but they can blend hydrogen with natural gas. And if we look at the technology, just from that perspective alone, a blended natural gas with hydrogen has a technology readiness level of about 7. That's good. That's near commercialization. It is commercialization. Pure hydrogen, instead of the blend, is about a TRL of 5. So there's more work to do to de-risk that. But the bigger question is not so much, will we be able to adapt our steelmaking process for hydrogen? I would say yes, we can, and we will. The bigger question is the hydrogen infrastructure itself, right? Because we need green hydrogen, which means we've got to have the electrolysis. We need the natural source of fresh water. We need renewable power to run the electrolysis. And we need the infrastructure to transport hydrogen. It's a different kind of pipeline. We need the storage centers to store hydrogen for when we need it. So that is a systems-wide challenge that kind of transcends the steel industry in itself. I know the energy sector is working on it. So I guess I would sum that up to say that when hydrogen is ready, and I say competitively ready, which means at the cost we need it to be and at the volumes that we need it to be, because the steel industry will have an insatiable appetite for hydrogen when the time is right. When the hydrogen sector is ready, the steel business will be ready to use it.
So hydrogen is interesting, as you said. It is available today. You can get hydrogen. The problem is the economics behind it. And that's where we really think it's important. And as we transition, that hydrogen is used where it can provide the biggest impact. And that biggest impact is in reduction. And in the case of the steel industry, the reduction of iron ore. Using hydrogen that's generally produced from electricity to make a gas and then burn that gas to make heat isn't the best way to use it. You're better off just using the electricity to make heat and implementing some things that electric heaters or rotary heaters that we talked about before. is the best way to use it today. Until it becomes crazy cheap, then sure, use it for heating purposes as well. But as it is today, it's expensive. So using it where it matters, where it can be used best, is most important. In terms of adaptation, there's some interesting things happening around the world. Coke oven gas, as we know, is about 50% hydrogen content. And in China, for example, Hebei Iron and Steel have built a DRI module running on coke oven gas. So it's not entirely green, but instead of burning coke oven gas to make power or using it as a heating source in other areas of the plant, they're taking that coke oven gas and using it in the DRI module to reduce iron ore. Makes a lot of sense. And so seeing that implemented over time, I think is going to build the confidence and going to build the transition.
Yeah, I agree. I want to emphasize too. I also support the position that electrification is a better way to heat, to reheat, to dry, and anneal. And those processes today are using natural gas or fuel oil or even coal in some instances. The evolution of hydrogen is going to evolve from the regions without natural gas. They will drive the development of hydrogen. So the EU, Japan as an example, I'm not so sure that North America will drive hydrogen as a gas development. We'll certainly be involved, but I think it's important to look at case studies like Stegra in Sweden is a hydrogen-ready steel plant under construction as we speak. And they will be a real case study for the viability of hydrogen reduction for steel making. And I think we're going to learn a lot from Stegra's efforts here. And then hydrogen evolution will happen from there.
Mm-hmm.
Yeah, and Stegra is really interesting from a case point. It's built in the north of Sweden, where they have a unique opportunity to leverage very, very clean and abundant green power. So it makes sense to them. One area I'm excited about personally is turquoise hydrogen. So that's using natural gas to make hydrogen through a methane pyrolysis process. So you still need electricity. So you only need a fraction of the clean electricity to make that process operate and produce hydrogen. And then the nice thing is the carbon part of the pyrolysis process is already sequestered. It comes in a solid carbon, already sequestered form, such that it can be readily disposed of or used in other processes that need that carbon.
Well, this has been a very interesting conversation so far.
Yeah.
We've talked a bunch on technology advancements. I'd like to shift gears to green premiums. So there's been much talk of green premiums of steel with low GHG emissions. And we recently posed a question: do you believe end users are willing to pay a premium for sustainably produced steel? Yes, within the next 5 years. Not for at least 5 years. No, price drives decisions, or only if mandated by law.
No. Well, there doesn't seem to be any momentum, right, for a green steel premium to be paid by the market. And that's okay. I think what we're going to see happen, that society is always going to choose green, all things being equal, which also means the price, right? They're not going to want to pay a premium for it, but they're going to still choose it, all things being equal. If we look at our investment community behind the steel industry, they want us to decarbonize. Our customers want greener steels to sell to their customers. And I would add that society, right? We, as people, we want to create a greener, more sustainable world. So we're going to get there, and we will get there to where there won't need to be a premium. As I said earlier, the genie is out of the bottle when it comes to decarbonization. He's not going back in. So what we have to think about is the transition era to where we can sustain our profitability to one day get to the net zero industry without a premium. to it.
Yeah, look, I do think there is an opportunity in the short term for a green steel premium. I think a lot of the consumers of steel, especially the automotive industry, have made pretty strong commitments to decarbonize, and that includes their whole value chain, and they're a big consumer of steel. So I think for a short time, there's a possibility of a green steel premium that first adopters can get. But I think over time, as more steel companies make the transition, the green steel premium goes away and the price of steel is just the price of steel. As we said, for those that do make the change, they need strong policy to protect them and help them maintain sustainable. As we know, margins in the steel industry, the steel producer is always in a tight balance between the price of raw materials and the price that they can sell their product to the market. And potentially that's where we may see a decoupling of the iron and steel industry, such that the energy intensive part of the steel making process, the iron making part of the process where the ore is reduced, could go somewhere else. It could go to places like the Middle East, where those countries are looking to diversify from an oil-based economy to potentially a metals-based economy. Could also happen in the US, where there's access to natural gas, there's access to carbon capture pipelines where CO2 can be sequestered. So that's a potentially interesting path that the steel plant could take, where the end products will still be made close to the end consumer in the regional locations, but where iron's made where it makes the most sense.
That's a great response, Paul. We're nearing the end of our time here. And in closing, I'd like to refer to our last survey question, and this is a specifically interesting one. Which of these do you hear most often from outside the steel industry? Steel is outdated and dirty. It can't be decarbonized. Apart from the tech revolution, and irrelevant to climate action. Ron, I'll pass it over to you.
Yeah, thanks, Takashi. That's a little disheartening, actually, to hear those kind of responses, but it's part of the society's perception of our industry, and we're working hard to overturn that. I think as far as process adaptation, the leading vote getter there, the industry is adapting its process for decarbonizing. That's happening. That will continue to happen. We will also be developing more markets for green steel. If you're going to make something, you got to have a market to sell it to, right? And those are two things that are underway and are not going to reverse course. What we really need to look at here to overcome these perceived negatives about the industry is we've got to make sure we have the green energy we need to do the job. So we've got to work with those utility providers. We have to work with our elected officials from a public policy perspective to really provide a transition environment conducive to being successful. We want to do this to win, without a doubt. And lastly, it's important that we sustain the business case through the transition. And by that, I mean we have to sustain our profitability as an industry as we venture out through this transition era. That is probably the most important aspect about what the future holds as far as I'm concerned. So if we support the research for all of this transition, and if we really pioneer the commercialization of all those technologies that we saw in the roadmap, and if we become enthusiastic as an industry to really be early adopters and not late followers to technology, then we will be creating an industry that is safe, that's green, and that's smart. And that's going to change society's perception of our contribution. If we get it right, we're going to win new markets for our industry, for green steel. We're going to be much more attractive to the next generation workforce. And we're going to improve quality of life on the planet, right? Those are very admirable ideals to aspire.
So I got a few points, and I'll touch on one there. Quality of life. Steel is absolutely essential to modern life. Everything we do, everything we touch involves steel. The perception that it's an old industry is completely wrong, as you know, Ron.
Yeah.
But there is a public perception that's out there that all of us are looking to change. In my time in the steel industry, I've seen phenomenal change, phenomenal advancements, and massive increases in efficiency and energy efficiency in making steel. And that's only going to continue. It is going to change by region. Every region is going to take its own path and will go at its own speed, depending on the age of their facilities, their existing facilities, and the money available to make the transition. Especially, are very excited about being part of that transition in terms of working with all of the stakeholders in the steel value chain to really accelerate the transition from or into a greener steel production.
Thank you for an exciting discussion today. We are nearing the end of our time here. I hope you've both had a good time, and special thanks to you, Ron, for joining us in our journey to steel industries.
You're more than welcome. I was happy to be part of this effort. So thank you as well.
Yeah, I had a great time, and thanks again, Ron. It's been a pleasure having you here and having the opportunity to be on this podcast with you.
Thank you for joining us on Forging the Future, Decarbonizing the Steel Industry, where we navigate the complexities of iron and steel. We hope today's episode has provided you with valuable insights into the sustainable transformation of the industry. Remember, the path to decarbonization is a collaborative effort, and every step counts towards a greener future. I am your host, Takashi Sachdeva, and along with the entire team at Hatch, we appreciate your engagement and curiosity.